So yesterday I realized that I threw a lot at you and it's probably overwhelming. So we're going to slow our roll for the next couple days and then return to all the problems that were in that assignment from yesterday, this weekend. Right. So today's plan is to do the graphs of original functions and the graphs of derivatives. And then tomorrow we're going to look at the second derivative graphs and return to the assignment from yesterday. So when we're looking at the original graph, we're concerned primarily with our critical points. So critical points, remember, are where my first derivative equals 0. They're going to look like a max or a min, or just a spot where I have a tangent line slope of 0. Right. And once we've got those, we're going to look at increasing and decreasing on either side. And then we're going to concern ourselves with our inflection points, which are the points where we change concavity. All right, at those points, our second derivative is equal to 0. And this is where we change concavity. Once we do that, we're going to indicate concave up versus concave down, what intervals those are. All right. And something that we're going to return to again and again in the next portion is just the note that our second derivative is the rate of change in the first derivative. So the second derivative, I feel like I can't spell right now. Second derivative, I think that's right. Derivative is the slope of your first derivative. All right. We're not going to use that fact right now, but it is important to just remember that. Okay, so let's make our number line. So we've got three things we're going to be talking about. Our original function, our derivative, and our second derivative. So our original function has critical points at -3, -1, and 1. And then we have inflection points, because we go from concave down here, right, to concave up here. So we have an inflection point at -2. And another one at 0. So now let's look at concave up and down. We're concave down from -infinity all the way until -2. Right. These inflection points are where my second derivative equals 0. So I'm going to transfer that down to my second derivative, and the concave down means my second derivative is going to be negative. Then I've got concave up on my next interval from 2 to 0. So that's going to mean my second derivative is positive. I've got 0 there. Remember, inflection points of my second derivative equal to 0. Right. So to the right of 0, we've got that downward U shape, so we're concave down. So that's going to make our second derivative negative. Let's go back up top and think about increasing and decreasing. To the left of -3, we are going up, so we are increasing. When we're thinking about our first derivative graph, that critical point is going to be when our first derivative equals 0. And since we're increasing, we've got positive there. Our next critical point was at -1. Once again, our first derivative equals 0 at that point. Now we're looking to say, well, what is my function doing between -3 and -1? Well, it's going down, so it's decreasing, which means my first derivative is negative. And then between -1 and 1, we're going up, so I'm increasing. My first derivative is positive. At 1, I have a critical point, so I've got my f prime of 0, and after that I am decreasing, so my first derivative is negative. Alright, so now that we've got that information down, we are prepared to make our graphs. So the graph of f prime needs to have the characteristic that its y values are positive, positive, and then negative. Because when we're talking about the graph of f prime, the output is going to be f prime, which is our derivative. So that's going to be our y. And then if we're looking at our concave up and concave down, the second derivative, remember that tells us the slope of the first derivative graph. So I've got -2 here, which means my first derivative graph is going to be decreasing until -2. And it's going to be positive and then negative with my derivative equal to 0 at -3. So let's make some notes. Where the first derivative equals 0, that's going to be an x-intercept on this graph. And that's on my original graph. That's a critical point. So let's start by putting those right on our graph. Our critical points were at -3, 0, I'm sorry, not 0, yikes, -3, -1, and 1. To the left of -3, our derivative is positive, so we're going to be up here somewhere. Between -3 and -1, we're negative. Right? Once again, I'm looking at this first derivative bar here, and I'm saying positive, negative, positive, negative. And those are our outputs on this graph, because we're doing the graph of f prime. So then we've got positive between -1 and 1, so we just pick a point that's positive, positive in there. And then we've got negative output after 1, so we've got to pick a point that's negative. We should be decreasing until we get to -2, because remember f prime is the slope of our derivative graph. So at -2, I'm going to be decreasing until I get there. Okay. So this is -2, right? That's going to be where my second derivative equals 0. All right. And then I am increasing until I go to 0, because from -2 to 0 of my second derivative graph is positive. And then I've got f double prime is 0. Right. And then I'm decreasing afterward. So some things to notice here. These x-intercepts are our critical points, so that's where f prime equals 0. And then our maximum and minimum are going to be where our second derivative equals 0, because the slope of this graph of f prime is f double prime. So the inflection points of f of x, remember those are where our second derivative equals 0, become maxes and mins, or just general critical points on the graph of the first derivative. All right, so we have two characteristics that we're paying attention to. Just critical points of our original graph where f prime equals 0, and the inflection points of our original graph where f double prime equals 0. Key characteristics, those critical points from the original graph become our x-intercepts because we're talking about the graph of f prime here. Right, and our slope of f prime is going to be determined by the second derivative. Now with our second derivative graph, we have a little bit less information to go on. F prime is our output, so that means our inflection points from the original graph are going to become our x-intercepts. So inflection points of f of x are x-intercepts of our f double prime graph. And then we look at our concavity to determine where we should have positive and negative y values. To the left, I've got negative, right? And in between, I've got positive, concave up, concave down. And then to the right, I've got negative again. So my graph should look something like this, right? Where it's positive between -2 and 0 because our original graph was concave up between -2 and 0, and it's negative on either side because our original graph was negative, or concave down on either side of -2 and 0. So that's us putting our foot in the water with graphing the derivative and second derivative from the original function. Go ahead and try the next problem and then watch the video. Solution.